All right. Chapter 2 is looking at a little bit more details of technical drawings, and it's looking at layouts and lettering. Okay. And we're going to be spending, more time on these elements, but again, introduction here. So the objectives here are really to just kind of look at the basics of technical drawings and what we can expect to see on those drawings and how it's presented without looking at each one of these elements. So first of all, projections. When we look at an individual part, we need to relay what's going on in a way that everybody can understand it. And one way is to look at how that part is projected on the drawing. And so what we do, and I like to think of it as I kind of look at one side of the part and what do I see when I look straight on? Okay. When I look at, for instance, the front of it, and I'm just going to draw that. And that's what you see this person looking at that part straight on. And what do I see in that view? And what I do is I then project those points back. And if you would, it's kind of like, that's what I'm going to draw on my piece of paper, or that's what I'm going to draw on my screen. Okay. So that's that view. Then what I would do is I would take it and I would turn it 90 degrees and I would look, for instance, at the left side. And now I'm going to look straight onto the left side. And what do I see there? How do those lines project? And now I'm going to be looking at that there. So when we talk about projections, it's what do I see when I look at this particular way at that drawing or at that part, okay? And then I project that onto either my screen on my computer or on a piece of paper. Now, there are different types of projections. There's a lot of different types of projections. Now, I'm going to zoom in here just a couple. And what I want to do is I want to show you where we're going to be. So projections in general are how we're going to look at something and how we're going to draw it on a drawing, okay? We are going to go to the right-hand side here in the big bucket called parallel projections. And all that means is we're looking straight on and we're going to project parallel to those sides, on our view. Now, over on the right-hand side again, orthographic projection is where we live, okay? We are going to be properly orthographically projecting the views of a part on our drawing. This is where, if you've ever looked at a technical drawing for a mechanical part, usually there's about 3 views: front, top, right side. Those are probably the ones that we usually start with. You can have more or less depending on the details, and I'll talk about those rules and we'll develop those as we go along, depending on the details or how detailed that part is, but usually front, top, right side. That's where we're starting, okay? And what that means is when we look, they are going to be flat views. Zoom in here just a little bit, if I can. Those are going to be these flat views that are in line with one another across each one of those orthographically projected views. Okay, they're in line. And we'll be talking about and developing how to create these on CAD, and then also, how we see those and how to visualize. Now, shoots. I hit the wrong back button. Let me go back in. So sorry, oopsie. Number 1. There we go. And I need chapter 2. Sorry. Let me get back to here. Okay. So now as we look here down projected or orthographic projection, you can see that we also have an isometric view. When we do solid modeling, SolidWorks, for instance, you get to look forward to working on that next after AutoCAD. AutoCAD is just a 2D system. Okay. So we're going to be, if you would, drawing our views. I'm going to put in quotes manually using a computer, each one of the lines, each one of the points on our drawings. Okay. In AutoCAD. When we go to SolidWorks, we actually create a solid model like we see here. And then we start with the model first and we go backwards and it creates the projections for us on a drawing if that's what we're going to be outputting it for. So when we have SolidWorks, we're going to be adding what we call an isometric view, because usually, because we've created the model, it's easy to add that view up in the corner, just as plopping it literally. So, so in AutoCAD, we're going to be looking at these 3 orthographically projected views, but when we get to SolidWorks, we'll be able to add like these fancy isometrics, so you get a little bit more visual on there as well. Now, on our drawings, we need to know and understand the graphical language so that we can pass this off to somebody and they understand what the requirements are based on what we know to be relevant to the final function or how it's going to fit. So we need to understand and know what different line types are. So, and some vocabulary. So for here, it says drawing vocabulary. Drawing lines. We're going to see that there are different types of lines. There's dashed lines, there's solid and dashed lines that are together. And so we're going to be finding out, throughout the course, how and when it would be appropriate to use these types of lines. Additionally, we're going to have to letter appropriately. So not only are we going to be drawing the views, but we're going to have to add dimensions and notes so that somebody who's making it down the line knows, what they have to do. So anything that's special. And we're going to have to put lettering and notes on our drawings. We also need to identify the measuring system. The two measuring systems that we're going to be looking at are going to be metric and US customary. In the metric system, we deal with millimeters, we dimension in millimeters, and in the US customary, we dimension in inches, okay? Just those two. And then we're going to be identifying an appropriate scale, okay? We're always going to draw one-to-one scale, like the actual size, but when we pull in our border, that's when the scale is going to become important, like how can we fit it around that part that we just drew? And then that drawing border is going to have title blocks, okay? The title block is going to give us the important information, and usually, first and foremost, it's going to legally bind whatever's on that drawing to that company so that somebody else can't steal that idea. All right, so like copyright, that's going to be part of the title block, but it also lets us know what the name is, the part number, material, who drew it, what the units are, lots of stuff. Okay, so it's an important part of that process. So these are kind of things that we're going to be learning and applying as we go along. So let's look most specifically at lines. The first type of line is going to be a solid line. This is going to be used when we can see and actually visualize like the line or the surface on that view. So I can visually see it. So it's going to always be a solid line. And you're going to notice that we have different line weights or line thicknesses. These are going to be dictated by the standard. So if I have a visible line, for instance, that's going to outline a part, or it's going to be an edge that I see in a view, it's going to be identified, and we can assign that in the CAD software, like in a template, if you would, so that it has a heavier line weight, thicker, and that's what line weight means. Then if I create, for instance, a center line, you're going to notice here a center line is a thinner thickness than a visible line. A section line is going to be a thinner line than, a visible solid line. So you're going to be learning more about these elements. Now, a center line is going to identify for us the center or the axis of a cylindrical feature, not its edge, but where the actual center is going to be. Solid lines, on the other hand, are going to show us our edges, and the section lines are going to show us material that we cut through. Okay, they're showing it there. I just wanted to be sure. Another type of line that we're going to see is going to be our dimension lines, okay? So dimension lines are going to be the lines with the arrows and the extension lines that we have coming off of features. So on the right-hand side here, you can see a dimension line. This is the arrow, and in the middle is going to be the number. That's going to correspond to the units, to the size that I need to make that feature to. So in this case, the overall length, if you would, of this part is 86. And I would assume that that's 86 millimeters, not 86 inches, unless it's a really huge part. Normally with inches, we see decimals in back of them. Millimeters, very, very commonly, we don't for those. And then the extension line is going to be here. Cutting plane lines. This is just going to mean that we're going to cut through the parts that we can see internally to it. So again, not so much that you need to understand what that is, but notice that there are different looking lines for different purposes. Here's a short break line, long break line. This is a phantom line where we've got a long line, two short lines, two dashed lines, and then another long line, and then alternating. Then we've got a chain line. This is called a center line. We've got a long and a short dash, and then a long and then a short dash. And then the third type that I want to make sure you know, because this is going to be on that little quiz, I'm going to say in quotes, is a hidden line. A hidden line is going to be a dashed line, and this is going to be features that we don't necessarily see in that view on the outside edge of it, but we know they're on the inside. Okay. So those are going to be dashed lines for hidden lines. So visible lines are going to be solid. Dashed lines are going to be hidden features. And center lines are going to be the axes of cylindrical features. Okay. This is just kind of freehand. You're not going to do a lot of freehand. We're going to focus on the CAD. That's where we really need you to be, because that's going to be the focus that you're going to have when you get out in industry. Measurement systems. There are two measurement systems that we're going to be working with, US customary and the metric system. US customary is going to be in inches. Now, if I zoom in here a little bit on this part, okay, and I go up here, you're going to notice that the dimensions that we see here start in the upper left-hand corner. This is called ordinate dimensioning or zero baseline dimensioning. And they're identifying that upper left-hand corner as a 0, 0. For those who are CNC programmers, this is always nice when you have these, because they're giving you coordinates horizontally and vertically from that corner, which many times is how it is conveniently laid out with, programming G code and where those locations are. Now, as we look at our dimension here in inches, you'll notice that we have 2 decimal places in back. Okay, so this would mean that this is 2.15 inches, for instance, from or to the right of our left hand edge here. So that's going to be that dimension. And then from the 0 again, where this like little boss or this cutout edge is, we have 4.78 inches. Okay. Now, if we go down directly below, this is in millimeters, okay? And how do I know that's in millimeters? Just by the way that the dimensions are here. Notice that there are no decimal places in back of it. That's basically saying it's a 0 place millimeter dimension. Sometimes you'll see 1 decimal, but normally it's either going to be none or 1 for millimeters. And then inches are going to be 2, 3, maybe even 4 decimal places, okay? Just because their inches are bigger than millimeters are tiny. Okay, comparatively. Now, as we look over on the right-hand side and down in the bottom corner here, this is what we call dual dimensioning. There are companies out there that work in both English and metric units, and on one drawing, they're going to show both units. Primary units will be the ones that are outside. So you'll notice here that we have a 2-inch dimension, and then in the brackets is the conversion to metric units, as you see here. So they might have companies that make this product both in the United States and overseas, maybe in a country that works with metric units. Okay. So you can have individual or you can have dual dimensioning on one. The drawing scale. Now the drawing scale, this is kind of important because in our title block, we're going to be identifying what the drawing scale is. When we actually draw on our computer screen, it will always be 1-to-1. The scale comes in is how we're going to, if you would, scale the border to fit around our views, okay? Now, a way to determine, what is meant. So first of all, you're going to notice that we have full scale, that's 1-to-1. So for every inch that I draw, when I print it out, I'm going to see an inch on there, okay? But if I go to a 1-to-2 scale, that's half scale. And I like to think of it as, if I look at where my colon is here on 1-to-2 scale, because that's going to be what you see in the title block, if you just put a slash like a fraction, it would be 1/2 or 1/2. That's 1/2 scale. Okay, that's one easy way. Because sometimes you might look at it, if you don't know, if you're not sure, you're like, ooh, 1-to-2, is that half or is that 2 times? It's half because you put the slash where the colon is here. And if we look at twice the scale, that means from, what I drew it at, this is 2 times larger on my drawing border, you would show that as 2-to-1 scale. And again, if you put the slash there, it would be 2/1, which would be 2 times as large. Okay, so if you're wondering how to read that 2 colon or 1:2, that's how I think of it. I put the slash like a fraction where that colon is. Okay. That comes into play when we pull in drawing borders. Otherwise, we always draw 1-to-1 scale. Now, in the drawing border, we see some important information, and this is where we're going to see our scale as well. So in this case, you're going to notice that they give the company name, its address, and such. It gives a description, part number, tells us what the revision level is, what size that print is, and then right where they're circling here, this is the scale. Now, they say 1-to-24. So that means that's 1/24 scale. So you draw it 1-to-1, but you bring the drawing border in 24 times so that the drawing itself, the part itself, is 1 24ths on there, okay? So when you have really large parts to get them on a drawing border, like you see in this case, yeah, you have to scale pretty large amounts. But a very common ones are going to be like our 1/2 scale or 2:1 or 1/4 scale, usually those common like fractional numbers. I'm not going to talk about scales too much, except know that there are different scales for different purposes. And it's important that when you look at a scale, you understand what the actual units on it are. Okay. So this is a typical metric scale. This is an engineer scale. And what's nice about an engineer scale is that you'll notice that it looks like a little pyramid or a triangle here. So each one of those sides has multiple different units on it. So rather than having separate scales for metric and for English, you can have one scale. And as you turn it, it has different units of measure and scales on it as well. That's all I'm going to say about this. Okay. And then the other thing too, I know on the quiz I have, what are the units for the popular units for English? Those are going to be inches. And then for metric, it's going to always be millimeters on drawings, unless otherwise noted, but most often those two. Lettering. Lettering is important. When we put our dimensions and when we put any notes and when we fill in our title block, we want to make sure that all of the information is readable. So that means that we're not using any fancy fonts. You might be able to find fancy fonts when you're, putting them in there, but we don't use them. The standard says that we need to use sans serif. Okay. So you're going to notice that it's going to be like Roman numbers, or it's going to be the Arial, or in this case, the sans serif, because we want them to be very easy to read. Additionally, they have to be in its final form about 1/8 inch tall on the drawing. And I say about 1/8 inch, okay? So right around that, because that makes it readable for everybody. It's not too small, it's not too big. So when we look at our drawing, sometimes we're going to relook at it and we're going to be like, okay, if I would print this out, can somebody read those numbers? And if not, then you got to adjust your size of your fonts or your text, okay? But straightforward. We're not doing italics. We're not doing fancy stuff. We've got to be able to read it and for people to understand it easily. So they give us some examples here. This playbill would not ever be on a drawing, ever. Okay, we're going to use the boring ones, the ones that are just very basic. Okay. Drawing pencils. Now, when I started out in mechanical design, I got to draw on a big drafting board, and I would buy all these pencils, and different line types and different line widths would all be dictated by how soft or hard your lead was. Those were fun times. That was one of the reasons I got into this, because I loved art and I loved drawing, and this was it. But lucky for me, the year that I went out in industry, the first job I had was a CAD operator. So I never got to do what I had hoped I could do. So you aren't going to do this either, but know that this is kind of where our line widths came from. How soft or hard those leads were dictated how heavy or light the line weights were. So I would use, like, let's say a 5H for a hidden line, but for a visible line, I might use a 5B. Okay. And we had erasers and brushes, and it was so good. It was so good, but never got to do it. That's okay. But that's how they're related. So we didn't get rid of those ideas. It's just that they translate now to line widths that we just put on our CAD system. The other part that we lost, and this is just a tip of the cap to some really good engineers and designers that I had the privilege of working with. When you got drawings that would have been hand drawn by people, yes, everybody had to use kind of regular font, but you knew immediately if it was Mike Schramm's drawing or if it was Bob Green's drawing or whoever it might be, where you just picked up that drawing and without even looking at the title block or the initials, there was an art form there, during those times where I'm not saying we've lost that, but now everything is quite uniform. And those were kind of the cool things about days gone by, if you would. You'll probably be able to see and come across hand-drawn prints, and you'll kind of see some of those things come up, and you might even have the job of convert this to CAD because we need it now in our computer system. And that was actually my first job when I was working out in industry many years ago. It was a company that was converting all their hand drawings over to CAD. And so I had a stack, and I would go through, and that's all that I did was I put these into a CAD system. But anyway, but but these things came from, or our settings came from the things that they did by hand. There's also templates. You might see circle templates. So if you're making sketches and you want to have nice circles and stuff, sometimes it's not as easy to make a hand sketched circle as it may seem like it should be. So these were used for repetitive features that we would look. But now CAD tools have replaced all of that. And the CAD tool that you're going to be getting to know in this particular class is going to be AutoCAD. And then as you move along in the program, then you're going to be moving on to SolidWorks and parametric modeling. And what is nice about CAD is that you can have those settings that are going to be uniform, and now they're all the same for everybody. So it's a good thing. And then you can save everything digitally and not have physical prints. Model space and paper space and AutoCAD. So we're going to be working just in model space, but some companies utilize what they call paper space, and that's going to be what they call your viewport, or if you would, your title block. But we're going to be pulling the title block right into model space, which is the most common way of using AutoCAD. Sketching, using kind of paper that has grid on it to get like good results. But again, we're going to be focusing mostly on the CAD. Now, this is another important thing where sizes of our title blocks, okay? I'm going to scooch ahead to our next slide here. When we make a drawing, we're always going to put it on a title block. Now, at the beginning here, not right away, but as we progress in our course, we're going to be pulling title blocks in. And again, the title blocks give ownership to, for instance, the company. They also identify material, part number, part name, who drew it, when it was drawn, the scale, lots of information. And that is all going to be in these boxes down here, okay? Now, depending on the size of the part, it's going to be most appropriate to put it on different size borders, okay? So in the US customary units, we have 4 standard border sizes, and they start at the letter A, then they go to B, C, D, and then roll size would be the next ones. But these are our 4 main sizes, okay? Now, an A size border is a standard piece of paper. It's 8.5 by 11, okay? And it's, in this case, it's laying horizontally or in what would be landscape mode, right? The next size is a B size. If I take that 8.5 by 11 and I put it up on its end and I take one and I stack the next one next to it, this is an 11 by 17. So it's 2 A sizes, but shifted 90 degrees. Do you guys see that? So a B size is my next one, 11 by 17. Then a C size, we're going to take 2 B sizes, turn it on its end again, 90 degrees, and go 1, 2. That's a C size. And a D size is 2 C sizes on its end again, next to each other. So A, B, C, and D are the standard US customary drawing border sizes, okay? The corresponding, I'm going to go back, the corresponding metric, okay, are going to be, they all are A4, A3, A2, A1. A4 corresponds to, if I go to the right, an A size 8.5 by 11, okay? So A4 in metric is an A size 8.5 by 11 sheet of paper in English. The corresponding B size, or 11 by 17, is going to be an A3. And they just have millimeter conversions here, okay? So on this line, the top line corresponds to each one of those sizes, okay? Does that make sense to everybody? So we're going to predominantly be working in, probably most often in English, but you're going to have some examples of pulling in borders that are metric. And so understanding an A size border is equal to an A4 in metric. So we have to pull in the right border, because then the title block is all filled out with the appropriate information. Okay. All right. A title block, again, this kind of gives you generic. You're going to notice that when you go to different companies, they're going to put their own little spin on this, and they're going to have their logo and all that kind of stuff. But main information is going to be the company or the name. Our borders here at WCTC are WCTC borders. Okay. You're going to have a drawing title, drawing number, page code. That might be where in inventory it's going to be found. That can or can't be on a drawing. What the size is going to be, and such. So, so these are some main or elements that you're always going to see in a title block. Planning for your sketch. Again, this is going to be things that are going to come up a little bit later, but you're going to plan, like, what is your front view? And that's going to be something that we're going to talk more about in chapter 3 and planning those things out. And then what your right side, top view, and such will be. So this brings us to the end of chapter 2. Now, before I leave chapter 2, I am going to go back to our module. Okay. So in session 1 here, we covered both chapters 1 and chapters 2 in our tech drawing book. Okay. If we look at assignment 1A, you would now be ready to complete this assignment. Now, this assignment has this little airplane next to it. It's a Canvas, I'm going to, in quotes, say quiz. It's not an assignment. It's not I don't want to call it a quiz because it sounds like it's, I don't know. Quiz sounds scary sometimes. It's not a test or anything like that. But what it is you're going to go in and you're going to click, left click on it. And you're going to get the opportunity. Oh, see, it looks different for me. You're going to be able to like start it. Okay. And then what you're going to find is there's going to be short answer or they call it essay, but it's short answer, multiple choice, and true false. And based on the information that we just went over in these 2 chapters, you should be able to answer all of the questions. So it's concept related to what's in our tech drawing book here. Okay. Open book, open note, open neighbor. I mean, if you want to bounce off like, hey, what did you get for this one? I wasn't exactly sure, but don't be like, A, B, B, and then go down. Don't cheat, but you can use each other. Now for this assignment, let me just double check. You get 2 attempts. Okay. Oh, I'm not seeing it here. You get 2 attempts and you get the first attempt and then it'll show you what you got right and what you got wrong. I do need to correct before you get your final grade. I need to correct your essay questions. It can't automatically correct those. And I think there's like 3 or 4 of those, but you'll have your answers for the multiple choice, true, false. And I think there's 1 matching. So you'll be able to do that and you'll kind of have a partial grade. Then it'll trigger me to go in and finish grading it. And I'll grade your answers on your other ones. If there's anything that you got wrong, you'll be able to go back in and make any corrections for the full points back before the 7-day grace period is done. Does that make sense to everybody? Okay. So that's going to be what you would be ready to do assignment 1A. Now, again, this isn't due until the end of the week. It's due on Friday. Okay. Set due date, but then you got a 7-day grace period after that. Okay. The next time we get together, we're going to be done tonight. The next time we get together, we're going to go to session 2. Session 2 is now we're going to kind of start playing around with AutoCAD. Okay. So between tonight and Wednesday, I encourage you that if you want to have the flexibility of being able to access AutoCAD off campus, feel free at the top of our modules here, try one of these methods. Okay. Again, preferable to be locally loaded, downloaded from the website. If you do have slow internet, that's okay. If you want to download it here at WCTC, that's a great idea because then it just takes literally probably 20 minutes as opposed to maybe an hour, hour and a half. Not that an hour and a half is bad, but you do save a little bit of time. And remember, when you register for this out there, you have to use your WCTC email. Otherwise, it's not gonna give you permissions for it. And then Oporto is your other plan B. Okay. Now, again, if you're like, I don't want to worry about AutoCAD, I don't need it, I'm going to plan on being at school all the time, totally fine. Totally fine. Okay. And then also the next time we get together, if anybody wants to take that Zoom option, feel free to log on, be on a couple minutes before class starts, and then we'll start promptly at our 5 o'clock time. And then, I'll let you in and do that. I encourage everybody to at least try it at some point during the term because I think it's good for just in case. Okay. All right. Any questions? All right. I'm going to stop recording at this point.